going on, guys? My name is Cristian Clemente and welcome to my final project in IT 604 entitled Modulation and Encoding. Now, in order to understand what exactly modulation and encoding is, we first take a look at what modulation is. Modulation. Modulation is converting binary data or a low-pass analog signal to a band-pass analog signal. It's called modulation. The process of mixing a low signal with a high signal so as to transmit it through long distance is called modulation. In this process, an intelligent signal is mixed to a correct signal. Modulation for what reason? First, the information such as sound is represented by the modulation of the signal. A signal is modulated when one of its parameters changes with time. I will discuss both amplitude and frequency modulation below. Another reason to modulate signal is interference. Once I start sending a signal of about 500 Hz, any other 500 Hz signal would interfere with it, so I could only broadcast one signal of addressable range frequencies in any region at a time. There are three basic types of modulation. First, amplitude modulation. In amplitude modulation, the amplitude of a transmission represents the signal. The second one is frequency modulation. Frequency modulation changes the frequency of the transmitted wave in the response to amplitude of the original signal. The last one is phase modulation. Phase modulation, in this process, the phase of the signal is varied. Next, I discuss to you the diagram of amplitude modulation. The carrier wave has a frequency in the kilohertz range. 600 on the AM dial is 600 kilohertz. So the antenna need only be 125 meter long. The initial signal is raised until it is completely positive. Then this positive version of the signal is used as the envelope that determines the amplitude of the transmitted wave. The transmitted wave can be broken down into its four components, and that information sent along with the wave is non-periodic. A Fourier transmission must be used. The collection of amplitude for the different components frequencies called a spectrum. This spectrum contains two groups of frequencies called side bands and upper bands. Here in the diagram, an original signal you can see B is the shifted signal and C is the transmitted signal in which an envelope can be seen clearly. Next, you can see the diagram of the frequency modulation. FM radio frequency are given in megahertz, and the number on your FM dial represents the frequency in megahertz of the carrier waves before it's modulated. Broadcasting at 100 megahertz requires an antenna 0.75 meter long, and the length of this antenna must be mentally adjustable to produce varying frequencies. The original signal for an FM transmission will typically have a bandwidth of 15 kHz. The bandwidth of transmitted signal will be much larger, typically around 200 kHz, since the frequency changes so much. Here in the diagram, a carrier signal wave, you can see there is no modulation. B, original signal which has to be modulated and can be seen clearly. And the C is transmitted signal which you can be seen with different slides frequencies. And the next one is phase modulation. Phase modulation, frequency, and phase modulation have become widely spread in the VHF range. One of the advantages of phase modulation is that easy to use. For example, VHF, direct transformation radio station which use phase modulation are among the simplest ones, but still remain as effective as the radio station that use single band modulation. In addition, phase modulation has other advantages. Thus, the power of a transmitter does not change during the modulation. It remains constant and equal the peak value. The transmitter power amplifier operates at constant signal amplitude, so there are no special requirements to its linearity. The transmitter does not require high power audio signal, so its scheme and design turned out to be simpler than a single band transmitter. During phase modulation, the pace of high-frequency oscillation varies in accordance with the sound signal. The maximum phase deviation experienced in radians is called a modulation index. When you can change the phase of the signal, the frequency also changes as the frequency is actually spread or the phase change over time. In general, the phase and frequency modulation are very similar. They differ only in the spectral composition of the modeling signal amplified to the modulator. During the pure sound modulation, the phase and the frequency modulation are distinguishable at all. Phase modulated signal at the modulator output has a constant modulation index at any modulation frequency. The difference of the phase modulation from the frequency one is that the latter requires a frequency detector to receive a frequency modulated signal. In this case of the phase modulation, you can receive a signal using a regular receiver with amplitude modulation. A small detoning on the receiver weakens one of the side bands so that a EM detector outputs a signal. One can also receive a modulated signal using single band modulation receivers. Frequency of the sound spectrum will be accentuated. Pulse code modulation, or PCM, is a method of analog signal encoding, which uses a series of short pulses for their transfer. Pulse code modulation is most widely applied in coding-decoding systems. It is also used to send coded signals through telephone networks. With the help of PCM, you can also digitize analog signals, and besides, this operation can be used for data of various nature. Video and audio data, telemetry data, the analog data transmitted using pulse code modulation may be left unchanged or reduced in volume by means of different coding methods. This feature is also widely used in various devices, despite the fact that it reduces the quality of the received signal to some extent. There are two types of pulse code modulation. Differential pulse code modulation encodes the signal in the form of difference between current and previous values. For audio data, this type of modulation reduces the required number of bits per sample by about 25%. Adaptive difference pulse code modulation is a form of differential pulse code modulation, which changes the quantization step to further reduce bandwidth requirements with a given signal-to-noise ratio. Practical application: first, main digital channel, digital 64K-bit stream. To obtain it, a pulse code modulation is applied to human voice in electronic form. Second, WAV, a computer file format for storage of sounds, music, and voice. Pulse amplitude modulation. An analog to digital conversion method is called pulse amplitude modulation, or PAM. This technique takes an analog signal, samples, and generates a series of pulses based on the result of the sampling. The term sampling means measuring the amplitude of the signal at equal intervals. In PAM, the original signal is sampled at equal intervals. PAM uses a technique called sample and hold. Sampling palm wave. In the sampling process, the magnitude of the analog signal is sampled regularly at uniform intervals. The obtained values are called samples. For a 4 kHz voice channel, the sampling rate is 8,000 Hz, which means the signal is sampled 8,000 times per second. The samples will then be converted to digital number.